talk about how to convert a polar form of a complex number. So usually we have the complex numbers a to bi, right? A plus bi. So, but the polar form is in this form, r e raised to I theta. So, do you know any of those symbols? Probably not. So, I am going to tell you how to convert them also. But at first, we should know what are the two axes in this. So, usually complex numbers are represented in a graph as real and imaginary graph. And the real graph is represented as the x-axis and the imaginary graph is represented as the y-axis. So, for example, if you are plotting the complex number 1 plus 1i, or you can say 1 plus I, in the graph, you will put it as 1 and 1. So, here you will put it. As the imaginary axis means that coordinate you have multiplied by I. So, for example, this is actually 1i or just I. So, 1 plus I here. So, now we are discussing about complex numbers. So, you know there are two axes, right? You can also represent this as a distance and a angle, or you can call it radians or argument. So, these two lines are there. What does it mean? Yes. So, radius you know how to find. So, for example, you have the point 1 here and 1i here. So, what is the, to find the angle of this, how do you find it? As we know how to find the, as we know the formula for Pythagoras theorem, a square plus b square is equal to c square. So, we can use this inside here as we have the real part here. So, just we will take the real part, square it, plus, and we will take the imaginary part also. But what is the distance here? Is it I? No, because we know the distance cannot be as imaginary value. So, we will take it as 1 as the multiplier of I. So, which is just an imaginary square is equal to the modulus square. This distance is the modulus. So, we can rearrange this as root of real square plus imaginary square. So, for this example, we can take real as 1 square plus 1 square, the whole root, which is root 2. So, the modulus we got as root 2. So, usually we have to find the theta also. This is called theta, but in this case it's the angle. So, to find the angle, we have to first think of it in a different way. So, as we learned, the sine of theta is usually represented as the vertical axis and the cos of theta is usually represented as the horizontal axis. So, to say that these two have some relation, you have to say sine of theta will be equal to some value, but the problem is this is at r, or what is it? It is modulus. So, you have to multiply by r, because usually in a triangle like this will be the sine theta and this will be cos theta. But this will always be 1. Even so, this is increasing by r, we will increase everything by r. So, r sine theta will be equal to, yes, the imaginary distance, which is 1. And we will take the r cos theta also, since it is also the horizontal angle. Cos theta is equal to, yes, 1 also. So now we have to find a formula which can substitute this as one single formula, which is tan theta. So as we know, tan theta is just sine of theta divided by cos of theta. So you will take r sine of theta and r cos of theta and divide them. Since this r and r cancel each other out, this formula doesn't change. So this answer, we got it as 1 by 1 or just 1. So we got tan of theta is equal to 1. We want the angle or the theta we want. So let's look at the trigonometry table. So in here, the tan of some number is 1. So we can represent it as tan inverse of 1 is equal to theta. So we can say that tan of minus 1 or tan inverse of 1 is theta. So can we check which one is this? Yes. So tan inverse of 1 is, we can say that it is 45 degrees or pi by 4. But we know that we can only write it in radians because we usually write the polar form in radians. So tan inverse of 1 is pi by 4. So to represent the form 1 plus I to the polar form, it will be root 2 e raised to I pi by 4. As you know, I means, you know what is I, which is the square root of negative 1. And e is just the base of the natural logarithm or ln. It's just a base of that. So we have learned how to convert polar form to, to convert complex numbers to its polar form. So now we have discussed how to convert them also. So the final formula for each one is modulus is equal to real square plus imaginary square the whole root, and theta is equal to tan inverse of imaginary by real. So these are the most important formulas for converting for each one.